Hey y'all, was working on these shafts and it occurred to me that I was using the wrong tool to get my measurements. Still within the ballpark, uh, didn't have any real issues with the measurement, but wanted to talk to you a minute about tool quality. And especially when you're dealing with machining, you're dealing with thousandths of an inch. So to give you a reference, here's a sheet of paper. And one sheet of paper let's see if I can get this over to you. So 0 is about where my thumbnail is. So this piece of paper is about 3 thousandths, 3 to 4 thousandths in thickness. Alright, so like I said, this paper is about 3 thousandths in thickness. So that doesn't seem like a whole lot when it comes to a piece of equipment or a piece of machinery or a part that's 3 foot long. But there are times you have to deal with tolerances plus or minus a thousandth. Thousandths is about the size of one hair width. So I mean, you're talking microscopic, minute differences that you have to work with. Tool quality comes into effect with that a lot, because depending on what your tool quality is, depends on how accurate you're going to be. So let's do a couple of things. So I have 3 different measuring tools here. This is the one that I used the first time. And I'm not going to tell you what brand it is, but it's one of the generic tool supply places, that you can go and you can always find a safe harbor there. So anyway, let's look at this. The first thing you want to do is open them up. These are digital, so they have a digital readout right here. But open them up, clean out the jaws, make sure there's no debris or particles in there. Pull them together and see what you've got. Here I'm showing a negative 1,000, so I know I'm off. So I hit 0, that zeroes it out. I'm good to start my reading. So we're going to come to the end of this part that I've turned, and I'm going to measure it. And I'm showing 2 inches, 501 thousandths. So there you go. So 2 inches, 501 thousandths. This is the generic. I think I paid $10 to $13 for those. They weren't expensive. So this is another brand. This isn't the most expensive brand you can buy out there, but it's a brand called Shopproof. I'm not even sure they're still in business, but I've had these for a while. Not sponsored by them, like I said, but these are good. Some of your nicer brands, more expensive brands, Mitutoyo, Starrett, Fowler, those are really high-end and very precise pieces of equipment, but you're going to pay for that precision. So these, like I said, are they're a brand called Shopproof. Don't know much about them. It's just the set I've had, and they're actually pretty accurate. I've never really had any problems with them. So on these are a dial indicator. So instead of a digital readout, you've got the dial right here. And to zero it, same thing. We're going to open it up. We're going to clean out the jaws, shut them, and then we're going to turn the ring on the dial right here to get 0 on the dial. So I've zeroed it, and let's see what we read. All right. So now I'm reading 2 inches, 492 thousandths. So that's 10 thousandths difference. That's 3 sheets of paper stacked up difference between this tool and this tool. So there's one more piece that I want to use, and it's even more precise. It's called a micrometer. You have a crescent shaped area here that fits around the cylinder. You've got an anvil and a piston or shaft here, and by turning this dial, the piston goes in until it makes contact with your surfaces. You've got a graduated cylinder here and a dial indicator here that tells you how big a diameter you have on your part. Alright, so the way this works, like I said, we'll slide it over our part. We're touching the anvil to the bottom of the part here. We're going to use the thimble screw on the top, and we'll turn it until we hear it click, and we'll click it a couple of times. That has a tensioner in it that when it reaches a specific tension, it clicks just like a torque wrench and won't let you tighten it anymore. So that way you know you get a good reading. Now the other thing I do is I'll slide it back and forth a couple of times to make sure I'm getting good contact. And once I do, so I've got 2 inches right here because this is a 2-inch to 3-inch caliper or micrometer. So this is a given 2 inches in here. There's a little bar I can put in here and test it to calibrate it. I come over here and I'm past the 4, which means I have 400 thousandths. And then there's 4 hash marks behind the 4. Each one of those hash marks is 25,000. So I'm at my 3rd hash mark, which means I've got 75 thousandths. So now I know I'm at 2 inches, 475 thousandths. Now look at this dial right here, the cylinder dial, and this is the one that you can turn. So by turning that, it's graduated to 25, so from 0 to 25. So that means every hash is 1,000th. So I'm sitting at 23,000th. So that means I have 475 thousandths plus 23 thousandths. So that takes me to 498. So I have 2 inches. This cylinder is 2 inches, 498 thousandths thick. Remember, the first tool that I looked at, the little safe harbor tool, I got 2 inches, 501 or 2 thousandths, something like that. The next tool, the shop proof, I got 2 inches, 499, 2 inches, 498. And this is calibrated every time I use it, so I know it's dead nuts accurate. So the quality of the tool that you buy has a lot to do with how accurate you can get. I'll use this one to rough it in and start getting close. But when I want to get into fine detail, I'll switch to this. And then for dead on accuracy, I'll go to the micrometer. Okay? So the quality tool you buy and you put in your shop directly correlates to the quality of work you can get out of your shop. Now in machining, there are other things you have to look at. Is your machine very capable of doing tight tolerances? Does it have a lot of slop in it? Does it have a lot of wobble? You want to make sure that you maintain your machines, and we'll talk about maintenance more in just a little while. Other things that can affect it: heat. Turning these, you'll see a ton of heat and smoke coming off. That's because it's generating a lot of heat. That can do a couple of things. The temperature affects the metal, so it heats and shrinks and expands as you work it. If you measure this while it's hot, let it cool completely down, and then come back and measure it, you could have depending on the steel, you could have anywhere from 1,000th difference to 10,000ths of a difference. So when you're machining, rough it in, leave 10, 20 thousandths, let it cool, and then come back and do your finish. That way you get an accurate reading. So it's not just the quality of the tools you buy, but it's also the technique you use. So make sure to get the best work you can, buy the best tool you can for the money you've got. Take your time. Don't rush the work, and use intervals to let the material cycle down and cool down. The other thing working it too fast and too hard can do is work harden the material. And if this material is supposed to be able to be flexible, you could make this a very rigid piece of metal, and it could shatter or crack the first time they use it by work hardening. So not only that, it wears your tools out, because now instead of cutting with a piece of metal that's supposed to be very easy and cut like butter, now it's cutting more like a diamond. So you want to be careful with that. Alright, so we've talked about dial calipers, the digital calipers, micrometers. Those are our tools that we use for accurate measurements. A way to tell if you've got a good set or not, because sometimes there are companies out there that you don't have to spend hundreds and hundreds of dollars on something to get a good quality set. Look at the construction. If you shake it, does it vibrate? Do you feel, stuff loose in it? If you shake this, you can actually hear stuff rattling. You can hear the gear wheel right here rattling back and forth. It's not to say this is a bad tool, it's just not as accurate as this tool. Another way to tell is when you roll it, when you slide it up and down the scale. Does it slide smooth, or does it jump, and do you feel bumps and ridges in it? Is it stiff? This one is kind of stiff, but it's very smooth. It doesn't bind up, it doesn't jump and vibrate. It's tight. That's why it's a little tougher to pull. It's not binding, it's just everything in it's tight. There's not a lot of play. This one, you can actually feel as you're turning it. Number one, you can feel some give, or backlash, meaning that when I turn this wheel, there's, like you turn a steering wheel, if you go all the way to the left and the wheels start turning, and then you go back to the right, there's a little bit of play in there before the wheel actually starts moving, especially in older cars. Same thing with this. You can feel a little bit of backlash in there. That backlash can affect your measurements. So on this one, there's almost no backlash. On this one. When I put my thumb on the wheel and I start moving it, the gauge starts moving. This one, when I start moving it, it doesn't start moving right away because there's backlash in this little wheel. So those are things you want to look at. Look at your gauges. Are they quality built gauges? Do they, are they tight? Are they waterproof, oil proof, things like that? On dial calipers, you want to make sure that this ring is snug, not super tight, but you want to make sure it's snug. It's not flopping around, because if it is, it can move while you're using it and you can get inaccurate measurements. So make sure that this is tight. The other thing you want to make sure that it has is a lock. This one's got a lock too. That's so when you get it to a measurement you want, you can tighten this, lock it down, and you're not going to lose that measurement. So these are great for your measurements, to get the final and definite measurements. This one is more for roughing. This one's more of a final measurement. I use both of them. I use the roughing one. If all I'm doing is roughing and I've just got to get it close, I'll use it, because the more you use them, the more they wear out. So I want to make my better calipers last longer than I can, because they're a better investment. Now, the thing with these is you want to shut the machine off to use them, because if this is spinning and you go to put it over the workpiece, it can actually grind the teeth out, or the arms out right here, and then you get inaccuracies. So every time you want to measure something, you have to turn the machine off, let your workpiece stop turning, and then you can measure it. To save time, another way I've learned to be more efficient is by using a set of these. I don't know if you can see those. Let me. There you go. So some people call them calipers, some people call them dividers. I'm not sure what the real name is, to be honest, but I use them as gauges. What I can do, I can take my dial calipers, put them over the piece, lock it down. I've got my measurement, but like I said, with this spinning, I don't want to put this over it because it'll wear these out. I can take and set these dividers to the same width as my dial calipers, and the way you do that is by adjusting this little screw right here. So by adjusting this in and out, it'll open these or close these dividers. Now what I can do with these is, while the machine's running, if I want to know if I'm close, these act as a go, no-go gauge. Meaning, if it won't go over the work, I've got to cut more off. If it will go over the work, I need to stop. I've either gone too far or I'm right where I need to be. So when I'm using these and I start getting where it's just about to go over, that's when I start stopping the work to measure with the dial calipers. This will get me close. This will get me dead on. Or excuse me, the dial calipers will get me closer. And then, I got too many tools up here. A micrometer will get me dead on. So, depending on what work you need to do, make sure that you have the right tool for the job, and it'll make things a lot more efficient for you.